Okay, so in this video, we're going to talk about fractions, improper fractions, and mixed numbers. Just an introduction, understanding what they are, and also at the end of the video, we'll discuss how to convert between mixed numbers and improper fractions. So the first fraction we're going to take a look at is 2/3. Okay, let's talk about a little terminology. The number on the bottom of a fraction, we call the denominator. And the number on the top, we call the numerator. Let's take a look at how I could represent this value, this fraction of 2/3. That'll help us to understand the significance of the denominator and the numerator. So the denominator tells me how many equal parts I'm breaking every whole into. Okay, when we talk about a whole, we mean the number 1. Okay, so in this case, I'm breaking my whole into 3 equal parts. My numerator, 2, tells me of those 3 equal parts, how many do I have? I have 2 of them. So if I had 2/3 of a chocolate bar, right, that's less than 1 whole chocolate bar, right? So this fraction is less than 1 whole. How many of these equal parts would I need to have a whole chocolate bar? I would need all 3 of those, right? 3/3, and that's equal to 1 whole, right? I could take that same chocolate bar and instead, what if I broke it into 4 equal parts? Well, what does this fraction represent? My denominator is going to be 4. Why? Because I broke my whole into 4 equal parts, and of those, how many do I have? 1 of them. Okay? What about now? Now, how many fourths do I have? I have 1, 2, 3 fourths. Okay? And how many fourths would I need to have a whole chocolate bar? I would need all 4 fourths. Okay, so 4 fourths is equal to 1. 3/3 is equal to 1. 4 fourths is equal to 1. How many fifths do you think would be equal to 1? Right? 5 fifths. Okay? Now, the thing that we've gone over thus far that fractions have the most in common with is division. Okay? You can actually think of this fraction bar as division, right? 2 divided by 3 is equal to 2/3. Okay? And so here, that can help us to understand also, right, have another understanding of why 3/3 is equal to 1. Because when I see 3/3, that's really 3 divided by 3, which we know is equal to 1. And 4 divided by 4 is equal to 1. Any number divided by itself is equal to 1, right? So I also know then that 101 101sts, that would give me 1 as well, right? So that's an important pattern for us to recognize, right? So this is 2/3, okay? 2/3, again, if we think about this as a chocolate bar, if I have 2/3 of a chocolate bar, I have less than the whole chocolate bar, right? When I have the whole chocolate bar, I have 3/3, or 1 whole chocolate bar, okay? How would I represent 4/3? Well, I can't fit 4/3 into 1 chocolate bar because the thirds tells me I'm breaking each chocolate bar into 3 pieces. So if I want another third, right, this is 1/3, and this is 1/3, and this is 1/3. So how would I show 4/3? Well, I need another chocolate bar, but not the whole thing, just 1 of the thirds, right? Now I have 1, 2, 3, 4/3, okay? 4/3 is more than 1, right? If I ate 4/3 of something, or I have 4/3, that's more than 1 whole. So this is what we call an improper fraction. Okay, when the numerator, the number on top, is larger than the denominator, that means the fraction is going to have a value that's larger, greater than, more than 1. And we call those fractions improper fractions. So let's take a look at another improper fraction and think about how I could represent it. Let's do 9/4. Okay, the denominator 4 tells me every whole that I have is going to be broken into 4 parts. So here's 1/4, 2, 3, 4. I need another whole with 4, 5, 6, 7, 8. And then I would need one more. 1, 2, right, 9. So the shaded area here, this represents 9/4. Okay, and we can see here, this is 4/4, this is another 4/4, and then this is 1/4. Okay, but what was that really important idea I just talked about, right? 4/4 is also equal to what? 1 whole. And this 4/4 is also equal to 1 whole. Okay? And 1 whole plus another 1 whole gives me 2. And then I have this 1/4 left over. Okay? So this is what we call a mixed number. Okay, so let's focus in on 9/4 and what the process is for efficiently converting it into a mixed number, right? We had just talked about how it's 2 and 1/4. So the way that we're going to ultimately do this is with long division. So it's a good little review. 9 divided by 4. So 9 goes inside, 4 here. Can 4 go into 9? Yes, it can, 2 times. 2 times 4 is 8. 9 minus 8 gives me 1 left over. But the problem is there's nothing left to bring down, right? So we already know our answer. Well, I see the 2, right? Where do I see the 1/4? Well, 1/4, right? So whatever I have left over, whatever we would call the remainder, that just becomes the fractional part of my mixed number. So 9/4, I did 9 divided by 4, goes in 2 times with 1 left over. So 2 and 1/4. Let's look at another example. Let's do 22/7. Okay, well, 22 divided by 7. Can 7 go into 2? No, it can't. Can it go into 22? It can 3 times, because 3 times 7 is 21. We get 1 left over. There's nothing left to bring down. So what does this become? It's going to become 1, not 1/4, but 1/7. We're dividing by 7. And remember that this fraction bar, we can think of it like division, right? That's why we're doing 9 divided by 4. That's why we're doing 22 divided by 7. So 22/7 is also equivalent to 3 and 1/7. Okay, this is the improper fraction form. This is the mixed number form. Okay, the last thing we're going to look at is how do I go from a mixed number to an improper fraction, right? We just covered to go from an improper fraction to a mixed number, we use long division. So let's take a look at how do we go from a mixed number to an improper fraction before we wrap up. Okay, so we're going to use the example of a mixed number 4.5. And let's think about this in terms of pizzas, okay? I have 4.5 pizzas. Now, when I turn it into an improper fraction, I'm basically just saying, how many half pizzas do I have? If I have 4.5 pizzas, how many half pizzas do I have? So let's draw it out. 1, 2, 3, 4. Here's my 4 whole pizzas, right? Here's my 4 whole pizzas, and then here's my half pizza. 4.5. When we turn it into a improper fraction, again, we're saying how many half pizzas do I have? So all these whole pizzas, I got to cut them in half. Okay? 1, 2, 3, 4, 5, 6, 7, 8. and then this gives me 9, okay? So 4.5 is equal to 9 halves. Now, if you think about, right, how many halves are there in each of these whole pizzas? 2. So another way to think about what I did here was I did 4 times 2, or 2 times 4, right? 2 times 4. And then we had this extra half pizza. What did I do then? I added it on. I had 8 halves plus 1 more gives me 9, right? So we multiply here. 2 times 4 gives me 8, plus 1 gives me 9 halves. Let's look at one last example. 5 3/7. I'm not going to draw it out. That would be a pain. But following this same pattern, right, well, and even thinking about it, we say, okay, I don't want to know how many wholes and then leftover sevenths we have. I just want to know how many sevenths. So each of these 5 wholes, I'm going to break into 7 sevenths. So 7 times 5, that'll get me 35 sevenths, plus 3 more, right? 7 times 5 plus 3, that's 35, plus 3 gets me 38. Okay, so this would be equal to 38 sevenths. Again, this we call a mixed number, 5 3/7, and it also can be expressed as an improper fraction, 38 sevenths. So I hope that this was a solid introduction to you to help you understand a little more about what fractions are, what type of fractions we call improper fractions, and then also how to turn those improper fractions into mixed numbers and vice versa. Once again, thanks for watching, and I'll catch you in the next one.